So today we're going to be learning about how to write written descriptions of graphs for your physics class or for any class, but they're super useful, super helpful, and pretty simple. So yeah. And you might be asking yourself, what is a written description? Sounds pretty straightforward, and it really is. A written description of a graph is when you describe what is happening in the graph and put it into words. So pretty much you're taking that picture and translating it into English words or whatever language, but today will be English. So there's four main factors you need to hit when you're writing your written descriptions. And those factors are the following. The first is the starting position. You need to identify where the object starts on the graph. Next, you need to identify the direction of motion the object is going in, whether that be positive, negative, or not moving. And that applies for every section of the graph. So each line that you see, you need to identify the direction of motion. You also need to identify the speed at which it is going in. So faster, slower, and when you have numbers, you can have a certain like miles per second or meters per second. But in our examples, we don't have exact numbers. And last but certainly not least, will be the time, how long it takes to get from point A to point B, from point B to C, C to D, so on and so forth. So you see these highlighted here, and there's certain colors, and for our examples, they will be coordinated with the colors as well. So the starting position will be in red, the direction of motion will be in orange, speed yellow, time green. So first we're going to start with our position versus time graph. And what we're going to do with this example and the next one is I'm going to read through it and then we're going to go back and break it down. So the object starts at a positive position, then moves in the negative direction for 4 seconds at a constant speed. Then it doesn't move for another 4 seconds and then moves for 1 second at its fastest speed in the positive direction. And finally, it doesn't move for the last 2 seconds. Okay, so the object starts at a positive position, identifying your starting position. We know it's positive here because on the y-axis, which is position, it is clearly at a positive point. It's not below zero, it's not at zero. It is a positive position. We're not sure exactly what the number is because we're not given exact numbers, but if you were to label it, you could put 1, 2, so we could say it starts at 2 meters. And then we see that it moves in the negative direction for 4 seconds at a constant speed. So we know it's moving in the negative direction because it's going down like this. We know it's going for 4 seconds because on the time x-axis, we see 1, 2, 3, 4 seconds at a constant speed. And we know it's going at a constant speed because it's not going up and down and switching positions, switching speeds. It's just boom, there. Then we see that it doesn't move for 4 seconds. So when this line is horizontally flat, we know it's not moving. And how we know it's for 4 seconds is again because of the 1, 2, 3, 4. And then for once, it moves for 1 second at its fastest speed. So we know it's for 1 second because of the 1 bar, and at its fastest speed because the slope is significantly higher than this slope we see originally. So the bigger the slope, the faster it's going. And it's in the positive direction because it's going up. And finally, it doesn't move for the last 2 seconds. So again, if it's this horizontal flat line, you know it's not moving. And we know it's for 2 seconds because of these 1, 2 tick marks. So that is the how to write a written description for a position versus time graph. Now we're looking at a velocity versus time graph. Now this one's kind of a little more complicated, but it's really simple once you get down to the nitty-gritties. So the object starts at an unknown position, and we know this because we're not given a position. It's not a position versus time graph, but we are able to see that it moves in the negative direction at a constant speed for 5 seconds. It doesn't move for 2 seconds, then moves at a faster pace in the positive direction for another 5 seconds. So again, starts at an unknown position. We don't know exactly where this position is, but we do know that it moves in the negative direction because it is below the x-axis, which means it's negative. It's below this 0 here. We know that it's going for 5 seconds because 1, 2, 3, 4, 5. 5 lines, 5 seconds. Then we see that it doesn't move for 2 seconds. Again, horizontal line, but you can see these are all horizontal. This one is special because it's on the x-axis, which means no movement at all. And we know for 2 seconds because tick 1, tick 2. Then moves at a faster pace in the positive direction for another 5 seconds. So how do we know it's going in a faster pace? I know it's going at a faster pace than the previous line because it's further away from the x-axis. So if it were to be 1, 2 tick marks away up here, then it would be moving at the same speed. But since it's 3, meaning 1 farther away from the x-axis, that means it's moving faster. And we know it's in the positive direction because it's on the upside of the x-axis for another 5 seconds. Again, 1, 2, 3, 4, 5. So pretty simple, straightforward. That's how you do velocity versus time graph. So yeah, thank you so much for watching. I hope this made things easier. Yeah, have a great rest of your day. Bye.